Hello ladies, so we're going to start Unit 4, which is our integration section. So just like in many of our math topics, when I have a particular function, for example multiplication, um, there has to be a way to undo your multiplication, which is division, right? Or if I have a square root to undo a square root, I need to square it. So if we're taking a derivative, there has to be a way to undo a derivative, and that process is called integration. So today we're going to take a look at basic integration, and then we'll continue in the next couple of lessons with some trig integration as well as the form of the chain rule for integration. So this is your Banana Blast packet on page 1. And the definition of integration is the antiderivative. So, like how let's see how we take a look at our different prefixes. Anti means the opposite of it. So antiderivative means I need to find the opposite of the derivative, which is the integration. It's the reverse form of whenever I take a derivative. So if you notice I have this symbol right here. It looks like a squiggly S, a skinny S, I would say. This is called your integration symbol, and that's the hint that you have to take an integral. And just from our notation, we also have to have a differential every time we have an integral. And so this is telling us what our variable needs to be when we're done answering. So I could have x's, y's, thetas, dt's, r's, any variable really, but we need to know that our integral must have that variable at the end. So let's take a look at how we've gotten to this process. So as of right now, the only thing we've done is taken derivatives. So let's take the derivative of this formula right here. And I'm going to get dy over dx, because the derivative of y is dy dx, is equal to 2x minus 4. Okay, so this is the derivative portion. But let's say I gave you a derivative and they said, well, where did this derivative come from? You have to be able to undo that derivative. So we're going to do some algebra. If you notice, I have x's and y's on the same side. I'm going to want to move all my variables so they are on the same side. If I do this, my dx's cancel, and I end up with a dy is equal to parentheses 2x minus 4 dx. So what we want to make sure we do is we don't distribute that dx. Remember, it's critical that we have a differential from the page before. So this right here, differential, oops, sorry, is a differential. That means we need to make sure we have these x's solved. So once I have this portion, what I need to do is to now take the integral of both sides. So just like in basic math, if I multiply on both sides on one side, I need to multiply on the other side. If I integrate on the left side, I need to integrate on the right side. And so we have to think backwards. What will give us a derivative of dy? Well, if you take a look at this, we realize that came from the letter y. So I know the integral of dy is y. Then I have to think, okay, well, how am I supposed to find where this 2x came from? So if you think about it, 2x we multiplied by the power, and then we subtracted 1, right? So the opposite of that is to add 1 and then divide by the power. So if I were to do this, if I added 1, I would get an x squared. If I divided by the power, 2 divided by 2 is 1. So I don't have a coefficient in this case, or my coefficient is 1, right? And then for the other side, by taking the derivative, what I did was I used the constant multiple rule. And so I was able to remove that x. And so if we were to do this, right, and technically, well, yeah, if we were to do this, we know that this 4 came from a 4x right here. So if you notice, an antiderivative is doing the opposite of what we did to get the derivative. So there are a couple of rules that we'll use instead of thinking, okay, well, where did this come from? There's patterns that we found, and so I have a couple of rules for you to take a look at. The first one is the constant rule. So if you notice, I have the integral of k, where k is a constant, so k equals a constant. Anytime I am taking the derivative, anytime I'm taking the integral of a constant, um, we know that we dropped a k. So in this example right here, what we notice is I have a 5 and I have a differential of dx. So if I follow the integration rule, my constant is 5, and then I will stick this x right here. Then I do have to add a plus c because I'm at an indefinite integral, which means I don't have a certain interval I'm looking at, so there has to be a constant that we have information for. And this is your answer. So anytime you have a constant by itself, all you do is stick the variable at the end, and that gives you the answer. So one thing we did learn was the power rule, right? The power rule was you move the power to the front and then you subtract 1 from the power. Well, to undo that, we need to use this integration rule where I add 1 to the power instead, and then I'm going to divide by the power. If you take a look, this is only true if n is not equal to 1. If n is equal to negative 1, then you notice we're going to have an undefined function. So there's actually a different integral that we'll learn later on to solve that. You're only allowed to use this rule here if n is not equal to negative 1. So let's take a look at this problem. I have the integral of x to the 4th dx. So according to this, I need to add 1 to the power. So 4 plus 1 is 5. And then I need to divide by the power. So that power is 5. I divide by this, and then I get a c. And if you want to check our work, if I were to take the derivative, and I derived, what I see is I get 5x to the 4th divided by 5, which if you notice is x to the 4th. And the derivative of any constant is 0, so I just have an imaginary plus there at the end. And if you look, this answer right here is the same thing as what was inside our integral. So that's the point of this whole section. So just remember, if I have a constant, I can stick an x at the end. If I have a power, I'm going to add 1 and then divide by the power. Okay? I have a couple more rules for you. Anytime I have a constant that's a constant multiplier, right? So for instance, this k is being multiplied by some kind of f of x function, then I'm allowed to pull out the k and then use the other rules that we've done. So if you take a look at this example, I have a negative 2x cubed dx. That negative 2 is a constant multiplier, so I'm going to pull it out, and then I'm going to integrate whatever's left over. Since I have a power, I'm going to need to use the power integration rule from the previous slide, and I'm going to add 1, so 3 plus 1 is 4, and then divide by the power, plus c. And then I'm going to need to simplify this, and I know these cancel, and I will get negative x to the 4th over 2 plus c. Go ahead and try to find the derivative of this, and if you do it correctly, you should get the answer right here. At the same time, if I have a plus or minus between certain functions, then I'm allowed to break up my integral. So if you notice in here, I have parentheses I have bracket f of x plus or minus g of x close bracket, dx. I'm actually allowed, if you wanted to say this, to break up the two functions, and then I would get two integrals this way. So that's one form, and then we'll learn to do the shortcuts in a minute. But what we'll do is I'm going to break this apart. And remember, this dx belongs to both pieces inside the parentheses, so I get x to the fifth dx plus the integral, and I use the plus sign because there's a plus sign right there, x dx. So I notice I have powers, so I'm going to add 1 to the power, which is a 6, divide by the power, plus I have an imaginary 1 here, so I'm going to get x squared divided by 2, and at the end I need to make sure I have that plus c. And then you're done. So these are some of the basic integration rules. What we'll do in the next section is we are going to take a look at we're doing an integral and then taking the derivative to make sure that we took the integral correctly, as well as combining all these 4 rules that we just learned. Alright, so go ahead and take a quick break and then come back for the part 2 of this section. Thank you.